So good evening, everyone, and welcome to our third online talk in science of 2021. For those new to us, my name is Wendy and I work in the public engagement team at Daresbury Laboratory, and we work for the Science and Technology Facilities Council, or STFC. Daresbury Laboratory is based in Cheshire and is one of 3 national STFC laboratories. Our other 2 are based in Edinburgh and Oxfordshire. So who is STFC? Well, STFC is one of Europe's largest research organisations. We enable the UK's natural sciences together with the computing and engineering communities to carry out their world-leading research. And we do this by working with universities, national laboratories like ourselves, regional campuses and scientific facilities right across the UK and abroad internationally. We study a whole range of amazing science, from the smallest particles that we know of, right through to objects in outer space and the mysteries of our universe. As you're no doubt aware, we cannot see or hear you, but we do have a questions and answer button at the bottom of your screen, so you can type your questions in there. Tonight's talk is very topical, so please don't be shy, as we love our audience participation, and the more questions we get, the better. Like many of our talks, this talk does not specifically cover STFC science, but what we hope to gain is for the audience to have a think about the topics that Professor MacDonald will raise, and to go away and find out more about them. Debate the issues raised with friends and family and look at the fors and against. Having these conversations will ultimately encourage informed opinions on the subject matter. The event is being recorded and we aim to finish at 7 o'clock best we can, but I believe there's quite a lot of content we have to get through in this talk tonight. So I would like to welcome Professor Averil MacDonald. Averil is an Emeritus Professor of Science Engagement at the University of Reading, and is currently Professor of Diversity and Inclusion at the University of Birmingham. Averil was awarded an OBE at the Queen's Birthday Honours List in 2015 for services to women in science. She has a host of awards for her engagement work, including Bragg Medal and Prize 1999, Woman of Outstanding Achievement in Science 2007, Honorary Doctorates by the University of York 2010 and Kingston University 2015, and the Base Starting Out Award 2016. I think I'm running out of fingers here. Averil is currently Master of the Worshipful Company of Fuellers in London and was previously Chair of the Trade Association representing the onshore oil and gas industry in the UK. Averil is Director of WISE, which is a campaign for women in science and engineering, a Trustee of the Science Museum in London, a Non-Executive Director of the Cheltenham Festivals, just take a breath, a member of the Women's Business Council, which advises the government on issues affecting women in employment. And she previously represented the UK on the EU Helsinki Group for Gender in Research and was a UK ambassador to the G7 Summit on Gender in Japan in 2016. Averil has advised numerous organisations and businesses on equality and diversity, including Network Rail, B&Q and numerous universities. What a CV that is, it's ridiculous. So Averil, I think I've done enough talking now, so I'm going to hand over to you. Thank you.
Okay, thank you. So I'm going to go straight in, so I'll share my screen, and if you could confirm you are seeing my screen.
Yes, that's perfect. We just need to go, that's right.
Yeah, there we go. So you're now excellent. So, well, thank you for all turning up to watch this. And as Wendy pointed out, there's a lot to get through. So it'll be a bit of a gallop. Do put your questions in the Q&A and we will get to them at the end, as many of them as we can. So, protecting the planet, myths and facts. There's a lot that people can find out about how to work best to protect the planet, something we'll want to do. But it worries me sometimes that there are things that get put out there that will be accepted as a good idea, whereas we should think about what we're told is good or bad for the planet to be absolutely certain it does have the consequences that we want. Sometimes an action that sounds a good idea can have hidden or unintended consequences. So I'm going to suggest a number of things that you might have seen written in the newspapers or on the web that could be considered really more of a myth, and then give you the scientific facts. And you can follow up the facts because I'll be giving you the links and the research that leads to these facts. So I'm going to just dive straight in. Something people often, I hear them say, is let's ban plastic, let's go plastic free. And on the face of it, you can understand why. People say there's plastic everywhere. There's so much of it and we're just throwing it away. Really, we need to get rid of it because of the problems that it causes in landfill and in the oceans. But is it as simple as that? For a start, if you look around, there's a lot of things that we use in plastic that really, to be honest, are good. For example, years ago, paints were made with an oil-based material. Clearly, we didn't have iPhones, but what else would you make an iPhone out of? Non-stick frying pans only work because they're coated in a plastic coating. And bulletproof vests, believe it or not, are made of plastic, a polymer, the toughest material on earth. If you say to anyone, yes, it's a polymer, they won't believe you, but it is. My favourite's this one at the bottom that I found. You can even make prosthetic limbs out of a polymer that's named PET. I just thought that was brilliant. It's actually the same stuff that you make your plastic bottles out of. So if we were to go completely plastic free, there's an awful lot of things that we wouldn't have. So we do have to think carefully about what we really mean by plastic free. But let's backtrack a little bit. What do I mean by plastic, or should I say polymer? For the science people amongst you, you will know that polymers are materials made of atoms and molecules like everything else, but what sets them apart is that those atoms and molecules are linked together in a long chain. So you can visualize it a bit like a necklace, a chain of beads. But each of those beads is a little monomer, a little molecule, if you like. This is a monomer called ethylene oxide. You zip them together, you polymerize them to make the long chain. You've got polyethylene oxide. The word poly means many. And all of the polymers, all of the plastics that you ever find are broadly made of the same basic ingredients, hydrogen, carbon, and oxygen, plus a few others, yes. But those are the base materials that you make all plastics from. Now that in the base of it is fine. The issue arises when we try to make an object out of the polymer by cross-linking. And we cross-link by essentially making those chains sticky, and they stick together to make the molecule, the solid object that we're creating out of our plastic. Again, sounds fine until you realize the fact we cross-linked to make our polymer into an object means that actually, even though we send our plastics for recycling, there's not much we can do with them. Once you've made your polymer by cross-linking, it's incredibly difficult to recycle and reuse your polymer. And some of the polymer materials we use, for example, babies' nappies, they take a long time to degrade. If you have ever used disposable nappies, as I did with my 2 children, they're now in their 20s, those nappies have a longer life expectancy than the babies that wore them. And they go to landfill and they pile up. And if we're not careful, we'll be up to our necks in dirty nappies. So one of the problems we have with plastic, why people are concerned about plastic, is because you can't reuse a lot of the plastic that we currently make, and it doesn't degrade very quickly. I understand the problem. So what is it that we could do? We could perhaps incinerate. We could burn the polymer. But a lot of people are concerned about incinerating. Is incinerating really as bad for the environment as people tell us? Now, incinerating basically means taking whatever the object is, let's talk about polymers, and burning it in a very controlled environment. It isn't a giant bonfire. It's actually under very controlled, environmentally restricted burning. And that allows us to extract the energy from the oil that was originally used to make the polymer. It's a way of actually using the oil to make the polymer and borrowing the energy until such time as we then burn the oil. Now, the important thing is this: incinerators do not emit quantities of toxins in the way that people imply, because the Environment Agency has extremely strict emissions controls. And nobody can incinerate stuff without following those guidelines. If you're worried about toxins, you should really worry about fireworks on bonfire night. There's far more emitted from fireworks on bonfire night than from any incinerator. However, the world is not perfect. We still are possibly emitting carbon. This has to be dealt with. So we really need to develop carbon capture technology for working with incinerators. And for the young people in the audience, if you are looking to do something to improve the planet, a science-based qualification will help you do that better than any other qualification you could make. And we really need your ideas on how to use all the plastic that we've ever made over the years and thrown away into landfill, how we can then reuse it to extract the energy and still capture the carbon that is part of the original plastic. So there's a challenge for you. But even if we do have landfill, and even if we do incinerate, there's still those horrendous pictures that we see from Blue Planet about all of the plastics in the ocean. An awful problem. How do we stop this? Well, it's a myth, to be honest, that we can stop plastic waste in the ocean if we send it for recycling. We believe that by putting it in recycling, we're going to stop the problem, but actually it's not as simple as that. For example, there's some work being done by the Ellen MacArthur Foundation. And some of you will remember her as the lone yachtswoman who went around the world. She was so horrified by the plastic in the oceans that she set up a foundation to research this. And her foundation, and there's the link you can check for yourself, her foundation looked at where the plastic in the oceans is coming from. And they divided it into 3 areas: Europe and the US, Asia and the Pacific Rim, and the actual countries are listed at the bottom, and the rest of the world. Now, in your minds, I wonder which you think is the worst culprit. Is it Europe and the US? Is it Asia and the Pacific Rim? Or is it the rest of the world? And how much do they contribute each to the plastic in the oceans? Well, the correct answer is that. Our plastic waste doesn't end up in the oceans anywhere near as badly as you would think. While we may be doing the right thing, there's an awful lot of the plastic waste in the ocean is coming from other parts of the world where they don't have the facilities to recycle and reuse that we have. If we're genuinely keen to make sure that we do something about plastic in the oceans, we need to work collectively with other countries in the world. And it's not just that. There's another part of that same research that shows that 80% may come from us on land, but a fifth, 20% of plastic waste in the oceans comes from water-based activity, whether it's fishing or whether it's actually cruise liners. Lots of this material is already on the water, and a lot of it comes from 10 rivers, just 10 rivers across the whole of the world. None of them are in the UK and Europe. So I'm absolutely in agreement with anyone who says we must do something about the plastic waste in the oceans, but we can't solve it just by recycling our own waste. There's more to it than that. And then there's another issue people often think about. In the oceans, there's not just what floats on the top as the large quantities of plastic, there's the microplastics. Now, microplastics are just tiny little pieces of plastic, 5 millimeters or smaller. And they make up 10% of all of the plastic in the oceans. And these things that I've listed here are the sorts of things that can contribute to microplastics. There's the microbeads in cosmetics, there's bits from your clothing, there's the bits that wear off your tires. The reason your tires go bald is because bits wear off the tires, wash into the rainwater, into the gutters, into the rivers and into the oceans. City dust, all the plastic objects that we have, wear up, wear down. The bits of the plastic from your phone will get into the air, into the rain, into the gutter, into the river, into the ocean. And then the pellets, the bits that people use to make plastic objects. Now, again, in your heads, which do you think is the worst culprit? Which do you find most of in the microplastics that are in the oceans? If you were in the same room as me, I'd ask you personally, but the answer is your clothes. Washing your clothes are contributing more to the microplastics in the ocean than all of the other things. And your tires, every time you drive down the road, your tires slightly wearing away are contributing to the microplastics in the oceans. And the point about your clothing is there's a high probability that everything you're wearing at the moment has plastics, has polymers as part of it. Most of us, even when we're wearing a cotton shirt, it's actually got polymers in there to strengthen it so that it doesn't crease as badly as pure cotton. Now, when we wash our clothes, and particularly when we wash our clothes on warm water cycles, little bits from the end of those long chains break off. Imagine in your head that long chain of beads, little beads break off the end, wash into the wash water, out into the drains, ultimately into the oceans. If you're concerned about this, there's a number of things you can be doing. One is don't wash your clothes so often. Another is wash them on a cold water setting, not just cool, but cold water setting. And particularly if you're very worried, you can put them into a net bag so that they don't bash against the inside of the washing machine and break the bits off. But it's the warm water setting that is one of the worst elements. So this is one thing to think about, is when we read headlines about plastic waste and recycling and so on, look further into it as to what these things, what is actually causing the problems that we are worried about and what we should be doing to alleviate it. Now, people are saying, yes, okay, but even so, we can still do something here by, for example, banning food wrapping, okay? But is it necessarily such a good idea to ban plastic wrapping on foods? Well, if you were to stop plastic wrapping on food, the first unintended consequence you would get would be more of these things on the road. The point being that our food is delivered in these juggernauts, and the plastic wrapping, one, is lighter than anything else, paper, wood, cardboard, and it is thinner than anything else. So what you end up with is more of the food in each of these juggernauts and a lighter load. If you go over to non-plastic wrappings, you'll end up with a heavier load and more of these juggernauts to transport the same quantity as food. So it's not such a simple thing as simply saying, we won't go over to plastic and everything will be fine. Actually, using plastic means we get less air pollution from the juggernauts. But it goes further than that. Look at the humble cucumber. If you have a cucumber, you might wonder why we need plastic wrapping on it. And part of the reason is actually it makes it last longer. The point here is that if you have a cucumber without the wrapping on and it's sitting on your supermarket shelf, it lasts about 3 days before it starts to rot. If you have it a plastic wrapping on it, it'll last about 14 days. Now, we in the West waste about 1/3 of all of our food between farm and fork. A lot of it in the supermarket, a lot of it in our own fridges. So for every 3 tons, a ton is thrown away. And that thrown away food is rotting, it's emitting greenhouse gases. And it's not just cucumbers, there's a whole host of elements of food that last longer because of the plastic wrapping, and therefore it reduces food waste and it reduces the greenhouse gases that are emitted. So it's not as simple as you might think. Now you might say, well, in which case, let's look at biodegradable plastics. Biodegradable's got to be a good idea. And what people think about with biodegradable is you have your plastic object, you throw away the plastic, and then progressively it breaks down. But think again, what is actually happening here? Go back to those beads. It's breaking down. It means the beads are breaking apart from each other, but the beads still exist. The monomer still exists. Even though it's invisible, it's still in the environment. And in fact, there's an even worse issue here. If we are going to reuse our plastics, recycle our plastics into, for example, patio furniture, and you've got a biodegradable polymer mixed in amongst all the plastics that you're using to create your reused plastic patio furniture, what actually happens is that the biodegradable one starts falling apart. And I, for one, would not be happy if my new patio furniture started biodegrading. So we have to be very careful about where we use biodegradable. Indeed, there are so many things about plastics that make us say, well, surely we've got to find a way of getting rid of them. But to be honest, there are things that plastics do that nothing else can do. For example, they can be very helpful in an oil slick. Now, you're aware what an oil slick is. You've got a tanker, it crashes, breaks apart, the oil spills out, washes up on the shores, huge environmental disaster, very damaging, and kills the wildlife. At the moment, what we do is we spray a bit of detergent on the oil and we hope somehow that it will disperse. Not really very satisfactory. However, there is a team that has come up with that. May not look very exciting, but this stuff is a polymer. It's a gel. You spray that onto the oil as it floats on the surface of the ocean, and it traps the oil in the same way as the lining of a baby's disposable nappy traps the baby's urine. It is then trapped in this jelly layer. It can't wash up on the ocean, on the shore, and it can't damage wildlife. And what they discovered was that they can make the whole reaction reversible, so they can take the jelly-filled surface covering away, and they can extract the oil and they can sell it back to the oil companies. So for as long as we're using oil, we ought to be using polymers to make sure we're mopping up the problems that it causes. And that's an environmental benefit that plastics can bring. But actually, there's a whole set of medical benefits that plastics bring. There's a huge numbers of things that we couldn't do if plastic wasn't available to the medical profession. For example, if you've had an operation, particularly inside, as opposed to a superficial one, any dissolving stitches you may have had were polymers. People who've had cataract operation, the actual lens that they put inside the eyeball to improve the sight of the patient is plastic. If you have a heart problem, you can replace your valves or your veins for a bypass operation. Arthritis operations where people have knuckles or knee or hip joints, those have plastic components. And burns victims, particularly in disaster areas, can have a skin graft that is essentially a polymer skin coating. And that stays in place until the victim's skin regrows and it stops infection. And they've even discovered a mechanism of using a polymer liquid as a blood replacement in a disaster zone. The point being, you can't use normal blood because it needs to be kept cold. This is a temporary replacement while the victim is taken to a hospital. And there's all sorts of things coming in the future, which is like contact lenses, which monitor your blood sugar. You photograph your eye with your contact lens in, and the color that your phone picks up is a measure of your blood sugar. And even simple things, there are washing bags that dissolve in water to mean that you don't have to touch the dirty bed linen. And all of the PPE that we have been using in hospitals over the pandemic, it's all plastic. Transplants is an interesting one. Believe it or not, they are now using polymers to create organs for transplant. This is genuine. This is a bladder created from a polymer, transplanted successfully into an individual who had bladder cancer. And rather than having a bag on the outside to catch the urine, this was then implanted and operated quite normally. There's now work going on to create other organs for transplant. For example, you create a sort of network, a framework that resembles a liver, and you seed it with cells from the healthy part of the individual's liver. And this person who has liver failure will have that liver grown for them and transplanted into their body. And their liver failure can be treated quite quickly rather than having to wait until a donor dies and can donate their liver. And the same is being done. It's all experimental at this stage for kidney transplants. Imagine in the future, instead of having years on dialysis while you wait for a donor to come along, as soon as your kidneys start to fail, they can grow you a new kidney from your own cells and transplant the kidney. And you don't even have to worry about rejection. And you don't therefore have to have any suppressant drugs to stop you rejecting your kidney. So polymers have a huge role to play in transplants and in medicine. But actually, they have a very big role to play in the issue of climate change, because they are actually one of the big ways in which we can move forward to decarbonize, particularly the UK. Because we are moving to very difficult times. We've got to move away from fossil fuels, and we've got to move to a greener way of generating electricity. Sounds great, and it is, but it's not easy. And to explore this, I'm going to ask you a few more questions. Electricity. Which country do you think uses the most electricity per person? I'm going to give you half a dozen countries in alphabetical order, and I want you to decide for yourself which ones you think are at the top of the list and which towards the bottom. This is electricity per person, not total electricity. Now there's the countries in alphabetical order. Which one uses the most energy? The answer, Iceland. Iceland, it's not because it's cold. It is cold, but it's not because it's cold. The reason why Iceland uses more energy per person than any of the other countries is because actually the servers, such as the one that is being used to transmit my talk to you, the servers for the internet, an awful lot of them are located in Iceland. Iceland is very cold. It uses the cold of Iceland to keep the temperature of the servers down instead of having to use air conditioning. And in fact, if ever you're on a Zoom meeting like this, unless people really need to see your face, you should turn your video off, because otherwise you are using more energy, and this is energy in the server, not at your home necessarily, for somebody to watch you watch them. Now, it's true that Iceland has a lot of renewable energy, and that's another good reason for putting the servers in Iceland. However, renewable energy is often the geothermal. There is evidence now that they're extracting so much heat from underground in Iceland that the temperature of the rocks in Iceland is going down. So it's an interesting issue that it may sound like geothermal is renewable. It turns out it may not be. The calculations are showing that there is evidence that the temperature of the earth around Iceland is going down. Now there you have energy use per person according to countries. I wonder which country emits the most carbon. Again, I'm interested who emits the most carbon per person. And I'm going to give you 3 options now. Which one of these countries do you think emits the most carbon per person from their energy use? This is energy in every sense of the word, not just electricity. Well, the answer is the US. People always go on about China being the dirtiest country. It only emits half as much carbon per person as America, and we're not far behind. Now that, I think, is a surprise to a lot of people, but let's bring it closer to home. What about the carbon outputs in different towns around the UK? Which one, again, this is how much carbon per person do you think is emitted? I wonder if that's a surprise to you. London's only 3.6 tonnes of carbon per person per year. Middlesbrough, 12.5. Swansea, not far off, twice as much as Middlesbrough. And the reason is not because people in Swansea have a peculiar lifestyle, but because of the manufacturing that goes on in Swansea compared with London, which is strongly a service-based industry. So it's an interesting view as to what it is that is contributing to our carbon production. But whatever goes, we're all keen to reduce our carbon footprint. And as individuals, we may be very keen to say, well, one thing I'm going to do is I'm going to get myself a battery-powered car, because that's a way that I can reduce my carbon footprint. I'm not so convinced. I personally don't think battery-powered cars are a good thing. Now, I know why people think they're a good thing, because they look so neat and they look so green, and they certainly don't emit all of this terrible pollution from out the back. But actually, there's more to it than that. And to explain why, I need to take you back to the idea of where we get our electricity from in this country. Every time you use any electricity, whether you're charging your car or making yourself a cup of coffee, you switch something on, the electricity has to be generated somewhere. And the point to make here is it is generated at the time you use it. It is not left somewhere in a giant reservoir. It isn't waiting around. The minute you want to do something, you have to have that electricity generated. And there's a giant control centre somewhere towards the south of England where all of that is organised. Their job is to make sure that when you want your electricity for your instant hot water shower or your roast dinner or whatever it happens to be, charging your car, the electricity is created and sent to you. And most of the time, it's fairly easy to organise it. But if there's a particular TV programme on, what happens is that the electricity we demand varies enormously. This goes back to 2010, but it happens with many world events. The pinky coloured line shows what energy we used. On the left-hand side is how much electricity. On the bottom axis is the time from 2:30 in the afternoon till 5:30. The pinky line shows how much electricity we use over the afternoon of the 22nd of June that year. The blue one shows what happened when we were watching the football match, England versus Slovenia. And you notice the actual amount of electricity goes down and down and down until 2:45, half time. Suddenly it leaps up and immediately you know why. What did we do? We all went off and had a cup of tea instantly because we had to get back for the second half. And as we watched the second half, the amount that we were demanding went down because watching TV doesn't require a great deal of energy until full time. The people in the control centre had to make sure that that extra energy was needed. They had to switch on extra power stations. And the ones they switch on are the ones that are most controllable, gas-fired power stations, the ones that you can switch on and off when you need. Now, they've got to make sure they give you the right amount of energy. So how much energy are you using? This is a question to ask. You know how much energy you use at home because you pay for it. But how much are you using? How much is being made, generated for you across the country? Bear in mind, there's what you use in your home. There's all of the street lights and the traffic lights and the shops and the offices and the hospitals and the hotels and every other facility is using electricity. How much is used per person across the whole of the UK on average? Well, there's a quick calculation we can do. If we were to switch on all of our generation capacity at the same time, that's nuclear, gas, oil, a bit of coal still left over, water, wave power, the Norway in the hydropower, wind power, solar power, we would generate 60 gigawatts. That's 60,000 million watts, or 6 with 10 zeros after it, watts. That's how much we can generate. We cannot generate in the UK more than that. That is the maximum we can generate with all of our power stations going, as a round figure. Now, for today, the UK population, I've decided, despite the census on Sunday, is 60 million. And so how much are we actually using per person? Do a quick calculation, one divide the other. The answer is 8 kilowatt. That is how much we in the UK can generate per person, maximum. Okay, now we don't all use our maximum at the same time, which is good, but that is the limit. We are low. Italy, similar population to us, it can generate twice as much electricity. It is our infrastructure that limits us to a maximum of approximately 1 kilowatt each. Now, it does vary over the day and it does vary over the year. But what we have here shows you from midnight to midnight, the amount of electricity on the left-hand axis. And you can see that the lowest demand when we need least is in a summer day or a summer around about 5 o'clock in the morning. And the maximum is round about 6:30 in the evening in the middle of winter. And there are many times in the UK when we as a population need, demand and use pretty much all of the electricity that we are physically capable of using. In fact, it sometimes gets so close that the government will pay businesses to switch off what they are using so that there's enough for us as the citizens of the country. Now, why am I telling you all of this? Well, I'm going to go back to the electric cars here, because of course, electric cars are going to add to our demand when we want to charge them. There are 32 million cars in the UK. Imagine just a third of us decide to buy electric cars and recharge them. We come home from work, we plug them in as they sit parked outside our house, and assume we've all bought a nice little Nissan Leaf. A Nissan Leaf needs 8 kilowatts to charge it for several hours, depending on how low your battery's gone. Now imagine 10 million people, so a third of all the cars, decide to switch on their Nissan Leaf overnight. Work that out, it's 80 gigawatts. But we can only generate 60 gigawatts. So actually, the UK at the moment cannot generate enough electricity to charge even 1/3 of all the cars that are on the roads if they became electric. This is a big thing to worry about. And the reason, I'm going to miss something out, something's gone missing. Anyway, and the reason why we have a problem with this, we have another problem with this, is the cables themselves actually get hot. Underneath the road, you have cables bringing your electricity from your substation to your home. If we all plug in our cars at the same time, we're going to end up with so much electricity flowing through those cables, they're going to get really, really hot. We actually need to invent better cables to be able to transmit all of this electricity to all of these houses. Again, younger members of the audience, we really need people to do science qualifications to be able to work out how to deal with this issue. There are ideas about how to solve the problem. People are thinking about it. One would be actually randomly, people have their car chargers switched off in order to ration the amount of electricity that is being used in one area. But of course, that would be a bit annoying if you then wanted to go to work the next morning and your car hadn't been charged properly. We might have a system where you are charged a different price for the electricity that you're going to use, depending on how many other people are requesting electricity at the time. So there's sort of an eBay bidding system. And if your neighbour bids a higher price for electricity than you do, they get their car charged and you don't. These are all theoretical at the moment, but it is an issue to bear in mind because we can't actually generate enough electricity if we have battery powered cars, and you can't transmit it anyway because our national grid is too old. It's not robust enough. So that's something to bear in mind. But we have another issue. All of the electricity that we have, only a fraction of it is renewable. There's no way we can ever generate enough electricity from wind power. Although people talk about it, the idea that we can generate enough electricity for all our needs from wind power is a myth. Now, there's a plan for a lot of wind power, and I'm a great supporter of wind power as part of the solution. But the 40 gigawatts, that's 40,000 million watts of wind power that we are planning as part of the government's 10 steps, is still not the full amount that we need. 40 gigawatts, we're already using 60, and that's without the cars. And these turbines are colossal. They are not like the ones you see as you drive through hilly areas of the countryside. These things are close to the height of the Shard. They are enormous things, and we're having to put them out distant offshore positions in the sea, a very, very inhospitable environment. But even worse than that, think about it. If we're going to have 40 gigawatts of wind power, we actually need about 30,000 wind turbines because they're not all turning at the same time. You need more than the total that you're hoping to get. Now think about this. If we were to put up 5 a day around the country, that's about 1,500 a year. It'll take us 30 years. Now, we don't want to wait 30 years. If we're going to do it by 2030, another 10 years from now, we're supposed to be putting up about 1 an hour. That is the rate that we need to be putting up wind turbines if we're going to get anywhere near the 40 gigawatts that is planned. In case you're wondering, we're not putting them up at that rate. So this is the issue that I have with these electric cars. We can't actually, in the UK, generate enough electricity to charge very many cars. If you have an electric car, you need to hope your neighbours don't. Otherwise, the cables under your streets are going to get so hot trying to transmit that much energy, chances are the transformer's going to blow up. Now, it could work as long as you turn your house off. because we can't do houses and charging cars at the same time. However, there is another way. Personally, I think it's better to have electric cars that don't use batteries. They're still electric, but they don't use batteries. They use fuel cells, hydrogen fuel cells. I'm a great fan of hydrogen. I've been writing about it for 20 years and talking about it for pretty much the same length of time. It is possible to have a car that is electric, that has in it the same electric motor that is in a normal electric car, but instead of having a battery, you have a gadget called a fuel cell. The fuel cell makes electricity for you when you feed it hydrogen. So you feed it hydrogen, it mixes hydrogen with oxygen from the atmosphere, and that combination creates electricity and it creates water. The only output, the only pollutant, if you like, from a hydrogen fuel cell is water. And it doesn't just work for cars, it works for anything, including buses and HGVs. One thing to bear in mind, you can never get a battery-powered HGV. They can never be a battery powered because you can't get batteries that powerful. You can get hydrogen powered HGVs. So that's another reason why battery power isn't quite the brilliant solution everybody says. So it's my prediction that in a few years' time, we'll all be able to say we have the world's cleanest cars. And yes, you will be able to drink what comes out the back. Just don't try that yet. And indeed, our grandchildren will look back on this time and wonder what took us so long in moving from diesel and petrol to hydrogen, because we could have done this 20, 30 years ago. And they'll look up to us and say, Grandma, Granddad, is it true when you were young, you used to have this stuff called oil and you made it into petrol and you put it in your cars and you set fire to it just in front of your toes? And then you breathed all the stuff that came out the back, and you will say to your grandchildren, yes, afraid so. And they will say, yes, and you must have been mad, because this is the way, this is the future of transport in the UK. It has to be hydrogen. There's problems on the way. We have to put in lots of filling stations, but Japan's doing it, Germany's doing it. Why not Britain? But I've got another issue that I want to bring to your attention. The final myth: we should keep fossil fuels in the ground, not just because we're going over to hydrogen cars, but because people don't like fossil fuels, be it oil or gas, and believe they should be kept in the ground. I'm not so sure. I think there's something else we should think about here. Now, it's worth pointing out at this point, it's never true, even if you read it in the papers, that the UK ever generates all of its energy from renewable sources. It has never been true. It is not true under any circumstances. If you read it, whoever wrote it is wrong. The reason is journalists frequently mix up the word energy with electricity. Occasionally, we do generate all of our electricity from renewables, usually in May when it's windy and we're not using too much energy because it's warm, but it's rare. But most of the time, there's an awful lot of the rest of our energy use that isn't covered by renewables. For example, how do you heat your home? Chances are a lot of you heat your home using gas. 84% of us in the UK have gas central heating. Now, this little graph that I've got here, the blue zigzag line across the bottom is the energy we use, the power we use, that I should say, from electricity. This is the 60 gigawatts, right? So that's how much electricity we use across the year from January to December. The red zigzag line is how much heat, in other words, how much gas we use, how much power we use from gas. The 60 gigawatts that we use in electricity is dwarfed by the up to 300 gigawatts of heat that we need for our gas central heating and our cooking, because most of us actually also cook on gas. 300 gigawatts. People often say we should be using electric for our heating. We can only generate 60 gigawatts. We can't generate enough to charge our cars. How on earth are we ever going to generate enough to heat our homes when we need 300 gigawatts of heat in the middle of the winter? This is the problem. And yet gas is a fossil fuel. And we are 23 million homes using gas as a fossil fuel. A third of our carbon footprint is from our heating, but we can't generate electricity to replace that heating. And insulating the homes, yes, it'll help, but it'll only save about 10%. So what are we going to do? Well, I believe it is possible to decarbonise our heating without electrifying. And it's important that we do it because we can't electrify. And the reason is this, because we've lined our gas pipes with plastic. Now, bear with me on this. You will have noticed gas pipes, when they're working in the road, have a yellow plastic inside. This is to make sure that the gas doesn't leak out. Now, the gas we are using at the moment, often called natural gas, is methane. It's got a carbon, it's actually CH4, 1 carbon and 4 hydrogen atoms. You burn it, you create carbon. However, we've got 3,500 kilometres of gas pipes feeding gas to our homes. Instead of saying we're never going to use those, we're going to cut off gas, we're going to stop using gas, we should in the UK repurpose the gas grid to carry hydrogen to our homes and then tweak our boilers, our central heating boilers and our cookers to burn hydrogen instead of methane. Hydrogen has no carbon. You burn it, you get heat, but you don't get any carbon. We in the UK are peculiarly well placed to do this. Most of Europe doesn't have miles and miles of gas pipes like we do. Only the Netherlands has substantial amounts of gas pipes because we are both facing the North Sea. Germany doesn't, France doesn't, Spain, Italy, they don't. They've never really adopted gas heating in the way we did, so they can't do this, but we can and we should. What we need to do is convert our gas central heating and our gas network across the country to a hydrogen system. And that will completely decarbonise the UK. Now you might think, how on earth do you do this? Well, this is where it gets really, really rather clever. Years and years ago, when your grandparents were tiny, each town made its own town gas. It was actually half hydrogen at the time, but it was dirty and it had carbon monoxide out of it when it burned. But we all had our own little gas supply to our own town. What that means is each town is self-contained. We could convert one town at a time to be working on hydrogen without actually switching off the whole country. All that happens is workmen come round, tweak your boiler, tweak your hob, everything's hydrogen. And we've done it before. That's how we converted from town gas to natural gas, exactly the same process. Now you're sitting there thinking, hang on a moment, that's fine, but where does the hydrogen come from? Good question. There are 2 good ideas and 1/3 brilliant one. Excuse me. One thing you can do, you can actually create hydrogen from water. Water, H2O, split it using electricity, gives you the hydrogen and the oxygen. You don't need the oxygen, let it out into the atmosphere, use the hydrogen, put it into our gas pipes. Now, the really clever bit is this. Frequently, wind turbines are turning in the middle of the night, 4 o'clock in the morning, when we don't need the electricity. Why don't we use that electricity that has no other purpose at 4 o'clock in the morning to power electrolyzers to create hydrogen? Create the hydrogen, pump it into our gas pipes, and it will stay there until the middle of the winter when we need it. That would be the most straightforward way of storing green energy. At the moment, when a wind turbine turns and we don't need the electricity, there's nothing much you can do with that electricity. Suddenly we've got a way of storing the green energy until we need it and then use it as hydrogen. But there's another way. Natural gas, methane, I said before, it's CH4, carbon and 4 hydrogens. You can decarbonize the natural gas, releasing the hydrogens for us to use in our central heating. And you sequester the carbon as a solid block, a carbonate. The clever thing here is this. Those carbonates, those solid blocks, resemble house bricks. What do we need in this country? Lots more houses. We've solved 2 problems in one go. We've decarbonized gas, so we've got hydrogen for our heating systems and for our cars. and we've sequestered the carbon in a carbonate to build our houses. Couldn't be better. So what we have here in my talk is very much decarbonising the UK. We do need lots of ways of generating electricity. We do need ways of reducing our demand. We do need ways of making sure that we can drive cars that don't rely on batteries. HGVs can't. And we do need to make sure we use hydrogen for central heating. We also need new ideas. It is not necessarily impossible, but to 2030, I think is pushing it. In addition, we do need to think about how we use plastic. It isn't the plastic that's the problem, it's the people. We are irresponsible. We need to be much more refined in the way we use plastic, and we certainly shouldn't be exporting our plastic waste. We should deal with it in situ. We can incinerate it, but we do need carbon capture. But again, we need better ideas as to how to make sure we use plastic sensibly. But I've left the best till last. This has got to be the best news you're going to have all day. In terms of plastics, there's one particularly good piece of news. There's now work in Bristol University where they're capable of growing polymers in a crest cell. That image is of a crest cell with the chloroplasts, the bit that does the photosynthesizing. And the chloroplasts, when they photosynthesize, create a polymer. Normally it would be starch, but this crest cell has been trained to create a polymer called PHB. That can be used for making objects. We don't any longer need to use oil. We can use natural-based polymers. But an even better piece of good news is back to hydrogen. If we do want hydrogen, we should thank the people at Birmingham University for their research, because they have discovered that there's an algae that will breathe out hydrogen if you feed it a particular bio waste. And it happens to be the waste from Cadbury's chocolate factory. If we are actually going to have a hydrogen future, we're going to have to eat more chocolate. So with that as an idea, I'm going to leave you with my links. Don't just accept what anyone ever tells you. Always check out the background facts. And those are things that I've offered you for you to check. So hopefully I have triggered a few questions. I'll now come out of screen share and let's see what we have.
So we do have a number of questions that have come in, Avril. I'll go right back to the beginning of the talk, if that's okay with you, because we had a question that came in quite early on, actually, from KA. A significant amount of these plastic rivers does come from plastic waste recycled in developed nations. That is then, illegally or otherwise, sent to developing nations, though. Therefore, those nations are not always the source nations. It's kind of a comment, but I'd like to hear what you have to say about that.
Yeah. Which is exactly what I came back to right at the end. We should not be exporting our plastic waste and expecting somebody else to deal with it. We should be dealing with it in situ, and we should lobby our councils as the people who collect the waste and our national government to say exporting is not acceptable. At the moment, it's a business. An individual agrees to get rid of the plastic and sells it on, and we don't actually look to see where it's going. So the individual asking the question is absolutely right, and the answer is we should lobby those people who are allowing it to be exported, and we should say, no, we're not prepared to allow them to export it. We should have the facilities here to deal with it. It's not good enough just to
those awful images on the telly with those mountains of
absolutely. Yeah, but the individual asking the question is absolutely right. And the answer is we shouldn't be exporting it. We should be dealing with it but at the moment we seem to do out of sight, out of mind. Well, we exported it, it's not our fault. And on paper, it looks like it isn't. But
we've all got a part to play in that, I expect. Brian is asking, hospital PPE, how is it recovered, recycled? Can it be done better? Because there must be a lot of it.
Okay, so the answer is, at the moment, there's no definitive process. But there are groups in different universities looking at mechanisms for recycling. But thinking back to the fact that PPE wasn't really an issue until this time last year, it's only now that suddenly it has reared its head. But the answer is scientists are looking at mechanisms, but it's still work in progress. So the answer is we don't actually have a good answer yet.
Interesting. Paul is asking, why is there not a big drive to push fuel cell cars at the moment? Why are we being pushed down the electricity battery model?
I wish I knew. My answer to that is there are many countries for which electric battery cars are a very reasonable solution because they have plenty of excess electricity generation. So America, the Tesla, it's not a problem there. What is happening here is that the same lobby, the people who make the cars and the batteries, are saying, oh, do the same in Britain. And nobody's really said, well, hang on a moment, what are the consequences? So we need to start lobbying to say, actually, council putting in these charging points, are you sure there's enough electricity to charge all the cars? The answer is, actually, we didn't look, but now you mention it, probably not. Now, it is true now, the government and BEIS, the Department for Business, Energy and Industrial Strategy, has started to adopt the hydrogen mantra. So it's getting there, but we need, as the consumers, to start saying to the car companies, no, I want a hydrogen car. And indeed, I'm in the middle of Monmouth at the moment, just down the road in Abergavenny, there is a hydrogen car company and a hydrogen filling station. So these things are happening. And I can guarantee for anyone watching this who has not heard about the hydrogen up until now, suddenly it'll be everywhere. Google hydrogen, it is everywhere.
Yeah, and lots of money to be made in it, I'm sure.
Oh, invest in fuel cells.
Yeah, Caroline is saying, don't we use electricity to generate hydrogen though?
You're right, but my point is this, if we've got plenty of offshore wind, which we're going to have, there's times when we won't be using it, so we then use it to make hydrogen. That's my point. We'll have so much offshore wind that won't be needed in the middle of the night, 4 o'clock in the morning. So we have to use that. So the more renewable electricity we have available, the more we can then use it when it's not needed to make hydrogen. I'm not suggesting you generate it just to make hydrogen.
Okay. Susan is saying, do you consider it a problem that hydrogen is explosive when looking at hydrogen fuel cells? I did wonder that myself.
All right, okay. It is the case that hydrogen can be made to explode. Most people who are thinking of this are thinking of one of two things. One, the squeak or the pop test when they were in chemistry lessons, but that's actually a trick. You have to get the right combinations. And the other is the Hindenburg, where they have seen the airship go up in flames. If you are remembering the Hindenburg, go back and look at the film. It's the skin that goes up in flames and not the hydrogen. However, to answer the question sensibly, hydrogen is no more explosive than petrol vapor. But we are acclimatized to using petrol vapor. We don't mind making it explode. And indeed, it explodes every time we put our foot on the accelerator. We're not setting fire to the hydrogen in the car. That's number one. So it's different. Secondly, the hydrogen isn't held as a gas in the canister, the fuel tank, if you like. It's held as a pseudo liquid. It isn't cold and compressed, but it's in a pseudo liquid because of the fact that it's sitting on fibrils. This is where the chemists have more expertise than I have, but basically it isn't gas, so it's not going to explode. However, I will contrast it with a battery car. If a battery car goes up in flames, it cannot be put out. It has to burn itself out because lithium, like sodium, just burns. You can put whatever you like on it, it won't go out. So anytime your battery car goes up in flames, it's a complete write-off, and they are known to go up in flames. So it's no less, it's no more dangerous than anything else we've ever done, and indeed safety regulations mean we're making sure it's less dangerous.
Okay, great answer. Kathy is also saying, don't you think that greener energy is nuclear or even fusion as the first options over hydrogen?
Okay, so the problem with nuclear is it takes an awful long time to build the nuclear power station. We were building 3 and 2 of the developers have pulled out. We're now only building 1. It's already several years overdue. So I absolutely agree with you. We do need nuclear, certainly as the base load, but we can't wait that long. We have to be doing other things alongside. Fusion, when I was an undergraduate a very long time ago, I was told fusion would be ready in 30 years. Last time I heard a talk on fusion, they said fusion will be ready in 30 years. We can't afford to wait. It would be great when it comes, but we've got to get on with it now.
Yeah, it kind of does feel like we're at a sort of turning point at the moment, isn't it? Matthew is asking, I've heard that battery power cars need to cover a considerable mileage before they contribute in a positive way to the environment. Such is the environmental impact of the battery manufacturer. Is this true?
Yes, it is true. And again, this is an assumption that you're only worried about the amount of energy it uses physically in moving about. In fact, any new item you ever buy has a carbon footprint before you ever get it. If you're really serious about making sure that we have a green environment, you should use everything you have until the final moment before it completely dies. You shouldn't keep renewing things. So even an old car, don't buy a new one, use the old one as long as you can, because the energy used in creating it is part of its global footprint.
Right. Just was asking, how can it be that Norway and Sweden have the biggest growth in electric cars and can cope? So what is it they know that we don't?
Okay, well, for a start, they generate a lot of electricity through renewables. They have the ability to generate more electricity than we have, and they have a more robust grid because they rely on electricity for their heating. So they've actually got a better, stronger set of cables under the street, for example. Our national grid was put in the 60s and 70s at a time when nobody ever thought there would be anything like electric cars. And anybody who remembers the 60s and 70s will know we didn't use a lot of electricity. And the grid was put in assuming it would be renewed after 40 years. And that was 50 or 60 years ago. So our problem is old infrastructure. And we are not at the moment planning to renew it. So we can't just start using vast amounts of electricity when we don't actually have the infrastructure to transmit it.
Yeah, it's quite a complicated issue.
Yeah.
Because you could end up with a bit of a headache with all this, couldn't you? Errol is saying, how feasible is it to convert the current petrol diesel engines to hydrogen, save current infrastructure in terms of metal car structure?
I understand that it is physically possible to use hydrogen in a combustion engine, but I don't think anybody's thinking seriously of doing it. So it may be chemically and physically possible, but I don't think anybody sees it as, because of the cost of doing it, I suppose, I don't think anyone sees it as a viable option.
Ah, okay. So we're at 7 o'clock. We'll just take a couple more questions and think we might have to wrap up then. Glenn is asking, what about heat pumps for central heating? They need electricity to work, but a lot more efficient than burning gas.
Absolutely correct. Heat pumps can and should be used where they will fit, but not everybody can use a heat pump. If you have a ground source heat pump, you have to have an amount of ground to embed it in to extract the heat from the ground. And for people in flats, that's not possible. So although heat pumps work if you've got a decent garden, don't work if you're in a flat. But actually the amount of ground we need for a heat pump is bigger than people often think. And I've seen a calculation that says if the whole of Southampton was powered by heat pumps, you would need an area of land equal to the whole of Hampshire to provide that amount of heat. So it's part of the solution. Absolutely agree, it's part of the solution, but it's nowhere near the full solution. And to agree with the person asking the question, yeah, we'd still need to generate the extra electricity to produce the energy for the heat pump. But everything is a multiple solution thing. There is no one silver bullet.
Yeah, I mean, it's a kind of thing you could actually sit here all night having these debates, and it's absolutely interesting. We've had a lot of comments about how much people have enjoyed this talk because it's all about opening your mind and thinking about things from a different perspective. We haven't got through all of the questions, but we will make sure that they're answered and will be emailed out in a link with the recording. So there's a lot of thank yous in there. One person is asking actually if we could have the links. So what we might do, Averil, is share those links that you had on your slide, and I'll email them out to attendees afterwards. They can go away and find out a bit more information about this. So I just want to thank you for joining us, Averil, here today. The talk has been fascinating. Just to reiterate to our audience from the introduction, the reason that we wanted to have this talk was to open up the debate, because if we talk to friends and family and go away and find out more, I feel like I want to go and look at things in a bit more depth. I hear a lot about hydrogen, but I've never really read up much about it. So it's interested me to go forth and do that. And that's what we want everybody to do at home, and have these discussions around the table and in the living room with friends and family, because at the end of the day, we'll be a little bit more informed when we're thinking about things. So thank you for that. For those who attend our talks regularly, you'll know that our talks are listed on the Daresbury Laboratory social media pages. But for those new to us, that's where you will find out about new events. I'm currently working month to month, because I only booked you a month ago, didn't I, Averil, for this. Our next talk is going to be on the 24th of April, and we've got a lady called Dr. Anna Puszajski. Her talk is called Handmade, a Scientist's Search for Meaning Through Making. And it's about materials, science and craft. The talk will be all about what she has learned as a scientist when she's tried a hand at glass blowing, pottery, blacksmithing, stonemasonry, and apparently there's lots of storytelling in there. So I think it will be a nice family one. So finally, I'd like to thank Averil once again for delivering today's talk, plus Phil in the background, who works really hard looking after the webinar and the IT. I want to make a special thank you for Vicky, who's attended tonight from our sister laboratory down in Oxfordshire, who stepped in to help this evening. So thank you, Vicky. This is another bonus of the virtual events, because she never could have come up the M6 to help with this. So thank you to everybody for attending. If you could fill in the survey after the event, I would be really grateful, because we do read them all. I will be in touch soon with you, and thank you, Averil, and hope to see you next time. Thank you.